Hi everyone, and welcome back to Simplifying Data Science for Linguists, where we make complex data science concepts from UC Berkeley University data course easy to understand for those in the linguistics field. I'm Fatima Ali, a computational linguist, and today we're going to dive into some fundamental concepts in data science: correlation, causation, confounding variables, and randomization. I'll explain how these ideas connect and why they are crucial for linguists venturing into data science. Let's start with correlation. In linguistics, we often look at relationships between different language features. For example, imagine we're studying the relationship between the frequency of a particular sound and the ease with which people can recognize words that contain that sound. If we find that as the frequency of the sound increases, the recognition rate also increases. So here we found a correlation. But here's the key. Correlation does not imply causation. Just because two things are related doesn't mean one causes the other. This is a crucial distinction in data science. Now let's talk about causation. Causation means that one event directly leads to another. For instance, if we conduct an experiment and find that training people on a specific linguistic rule directly improves their ability to use that rule in conversation. So we are dealing with causation. In data science, establishing causation is more challenging than finding correlations. We need to be careful and use rigorous methods to ensure that what we are observing is truly a cause and effect relationship. Here's where it gets tricky. Sometimes we might think there's a causal relationship, but it could be due to a confounding variable. A confounder is an outside factor that influences both the independent variable, what we think is the cause, and the dependent variable, the effect. For example, suppose we are studying the relationship between dialect exposure and language learning speed. If we don't account for a confounder like various previous language learning experience, we might incorrectly attribute faster learning to dialect exposure when it's really due to their prior experience. To tackle confounding variables, we use randomization. In data science, randomization helps us create groups that are as similar as possible, except for the treatment we're studying. By randomizing, we ensure that any differences between groups are due to the chance and not some hidden confounding variable. In linguistics, we could randomize participants into different groups to study the effect of a new language learning methods, and randomization ensures that the groups are comparable, so we can confidently attribute differences in outcomes to the method we're testing. Now, why are these concepts so important for linguists studying data science? In linguistics, we often deal with complex data sets and relationships between variables. Understanding correlation, causation, confounding, and randomization allows us to design better studies, analyze data more accurately, and draw valid conclusions. Whether you're studying the impact of language policies, investigating patterns in language change, or exploring the effectiveness of language teaching methods, these concepts are foundational to make sense of your data. So that's a quick overview of how correlation, causation, confounding, and randomization are interconnected and why they are so crucial in data science, especially for linguists. I hope this helps you in your journey to mastering data science concepts. If you find this video helpful, don't forget to give it a thumbs up, share it with your fellow linguists, and subscribe to the channel for more simplified explanations. And see you in the next video. Bye.